This video introduces the Phyton ChipProg ISP2 family of in-system device programmers. This family is based on a common CPI2 engine. Currently, the family consists of two models, CPI2-B1 single channel and CPI2-Gx gang programmers. These device programmers are mostly intended for in-system programming of multi-PCB panels with practically unlimited number of target devices. Any mix of devices, microcontrollers, flash memory, programmable logic devices, etc., can be programmed in parallel by multi-channel device programmers, with each site of each working independently. As of today, the ChipProg ISP2 family supports about 50,000 microcontrollers, flash memory, and programmable logic devices. On-chip programming interfaces such as JTAG, single wire, SPI, I2C, UART, and others are supported. Support for new devices is always in the Phyton development pipeline. We gladly accept on-demand inquiry of supporting new devices required by our customers. Let us begin by discussing the single-channel CPI2-B1 device programmer. This palm-sized unit can be controlled from either a computer USB or Ethernet port. In many cases, the programmer can be powered from a USB port. In case of LAN control, it should be powered from an external 5-volt adapter. A 20-pin connector labeled Target is situated on the opposite side of the unit. This connector is intended to accommodate a 20-wire ribbon cable that outputs ISP signals for flashing target devices and power lines for supplying the target. 10 pins on this connector are dedicated for forming bidirectional ISP signals to be sent and received from the target device. 2 pins are dedicated for supplying power to the target board. Reprogramming signal functions is provided electronically in accordance with the device type chosen by the user. This allows usage of the same 20-wire ribbon cable for programming a variety of target devices. Each signal line in the ribbon cable is interspersed with a ground wire. This configuration reduces glitches on the ISP signal lines, improving signal-to-noise ratio. This allows the user to set a maximum clock frequency on the programmer. This also allows programming devices at the longest possible distances specified by the device. Some devices can be programmed at distances exceeding 5 meters or 16 feet. The default configuration of the programming kit includes a 6-inch ribbon cable. An identical 20-pin connector labeled Control is located on the long side of the programmer. It is intended for connecting input and output signals to and from the device, for example the PC or the automatic test equipment that controls the programmer. One of the signals is the start input. An external signal applied to this input launches the auto programming session. There are 3 programmer outputs that indicate the programmer status: busy, good, and error. Further, the connector has an input that controls switching the programmer to the standalone mode. 5 inputs are available for setting a job select code which enables the user to choose one of the 32 preset standalone jobs stored on the programmer's built-in SD card. On the top panel, the Start button can be seen, which is for manually launching the auto-programming session. 3 LEDs are also located here. Yellow indicates busy status, green for successful device programming, and red indicates programming failure. The CPI2-B1 kit also includes plastic brackets that can be easily inserted into 2 grooves on the unit case. This enables convenient mounting of device programmers on a standard DIN rail. This picture displays 4 CPI2-B1 programmers mounted on the DIN rail along with a USB hub. An example of this use case is that these 4 CPI2-B1 programmers are driven in the gang mode as a 4-site gang programming cluster. Moving along, we now turn our attention to the ChipProg ISP2 gang programmer. This multi-channel or gang programmer has a generic product designation CPI2-Gx. X represents the number of installed programming modules. The number of modules may vary from 2 to 7. The user defines the capacity of the programmer at purchase time. Programming capability can be upgraded at any time by adding more modules. Each dual inline module, or DIM for short, carries the same programming engine as the previously described single-site CPI2-B1 programmer. It is important to note that this means both CPI2-B1 and CPI2-Gx have the same timing and electrical characteristics. They only differ in the design form factor. Each programming module of CPI2-Gx has a built-in demultiplexer that can be enabled by a special license. Having this license allows the user to double the number of channels. In this case, each half works sequentially, e.g. 2 plus 2, 4 plus 4, 7 plus 7, and so on. The demultiplexer license is tied to the programmer's unique serial number, which is associated with and stored on the programmer's motherboard. Customers specify the product configuration they want by specifying code CPI2-GNN/MMV1. In this case, NN represents the quantity of modules installed in the programmer. The substring MM indicates a doubled number of channels that can be implemented in the programmer upon activation of internal demultiplexers. For example, the CPI2-G06/12V1 refers to a 6-channel gang device programmer with an option to enhance it to a 12-channel programmer for 6 plus 6 sequential device programming upon activation of the demultiplexer license. The power plug, USB, and Ethernet connectors are located on the face side of the programmer. Here we also see a 48-pin DIN control connector for connecting the ATE signals. That includes the signals for tasks such as launching the programming sites, selecting standalone jobs, and outputting the busy, good, and error status signals. Each site has its own control signals that enable it to control them independently. For example, launching all programming sites synchronously or asynchronously. The unit has 2 large 150-pin DIN connectors, target marked as Channel A and Channel B. The A channel is the default main channel that is always active. The B channel becomes active only upon acquisition and activation of the CPI2-DMUX license. Users may wish to make simpler connections of ISP signals inside test fixtures. For this use case, Phyton offers special transition boards that dock to channel A and B DIN connectors and split the signals into 7 20-pin headers. The headers enable easy connection of ISP signals to target devices by standard 20-wire ribbon cables. Very often, device programming is combined with functional testing of the boards that the programmed devices are installed on. For accurate functional tests, it is necessary to completely disconnect ISP signals from the target. For this purpose, Phyton offers 2 relay units, relay barrier and relay demultiplexer. Here you can see a relay demultiplexer docked to the gang programmer. It has a dual function: to split the A programming channel into 2 sequentially working channels, and to disconnect the programming channels from the target panel while it undergoes functional testing. Now let us summarize the overview of the CPI2-B1 and CPI2-Gx models. For development, testing, repair, or field service, the CPI2-B1 is the best and only choice among other Phyton ISPs. The major field of applications of both these ISPs is electronic manufacturing, the scale of which may vary. In some programming scenarios, it is possible to use either multiple CPI2-B1s connected in a programming cluster, or a CPI2-Gx programmer. Choosing between these alternatives requires considering the key parameters and properties of the two programmers in the family. In other use cases, it is clearer which programming unit or units is the better choice. In general, the scope and complexity of the programming task is the most important determining factor in choosing the correct Phyton product for an optimal programming solution. Future considerations may play a role as well. If it is anticipated that the number of programming targets on a unit will increase in the future, a slightly larger investment at the present time may enable the smoothest and most cost-effective upgrade path in the future. The CPI2-B1 programmer, either by itself or as part of a cluster, is the best solution for simpler programming tasks with fewer targets on a given board. A rough rule of thumb is that the CPI2-B1 programmer is best for up to 2 to 3 devices on the board. This is also the better choice if functional testing after programming is not required. Taking into account pricing when we compare two programming solutions with 4 and more programming channels, use of a CPI2-Gx gang programmer seems to be more economical. This becomes even more obvious if the programming speed is not that crucial and the timing allows you to use the advantage of demultiplex programming channels. Another helpful option is the availability of relay barriers and relay demultiplexers, which enable combining device programming with functional board testing. Single-channel CPI2-B1 programmers do not have built-in demultiplexers and relay modules. For more information about Phyton in-system device programmers, please visit our website, phyton.com.